So yesterday, we dove into 16, and we covered 16.1 and a little bit of 16.2. We're going to finish 16.2, and then get into 16.3.4. Yeah. So, if you don't have your notes still, if they're in your locker or whatever, don't worry about those. But if you have them, get them out. So, we talked yesterday about actions, events, sample space, how we can determine probability of an event. So guys, if you're just coming in, you need both of the sets of notes right here, 16.3 and 16.4. So, we looked at this one, right? We were talking about the sample space is 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We list the whole sample space. So, here, if the event is the spinner stops on an odd, we did even yesterday, didn't we?
Yep.
Yes?
Yes.
Yeah. So then if the probability stops on an odd, what is then the outcome that we're looking for? We'd say it's probability of...
We did odd yesterday.
That's what I thought. You just... that's why I asked like 3 times. So we already did odd.
Yeah. So
let's talk about even. We ended just talking very briefly. We didn't calculate it. But if we talk about even. So remember, 0 doesn't fall into either category. So my evens on my spinner, Ellie,
there would be 4.
are only 4 out of how many spaces on the spinner?
10.
10. So that would give me a 0.4 or a 40% chance. So now let's talk down here in the table, and we could keep doing different things. We could do probability of a prime or probability of, you can keep changing what numbers you're looking at. Yeah.
What is P?
Probability. So P always represents the probability. And then in the parentheses is what it is we're looking for, or what event, what outcome that we would like to see happen. So, in the table here, we're asking what will be the action, what will be the sample space, and what could be the event that we're looking for. So take a second. What is the action that you're doing, the sample space of all possible outcomes, and the event that you decide you're looking for based on what you see here?
It's cold over here. Wait, so is the
Sorry, I'll move the lamp away from the thing. I don't think it's really that cold. The door was just open. We just had Saul outside.
I'm hot.
Yeah, I'm not.
Yeah, I think it's kind of cool. Ozzy, what in the first one is the action that we take with that?
I'm rolling the dice.
Yeah, my action is going to be that we roll. Fits in the Tantrum, has that new song. Roll up or on or something like that. The sample space here, Mr. Hoover.
Is 6?
We talked really specifically the other day. When we're asked about the sample space, we're not being asked how many, we're being asked what events, what outcomes are in the sample space. What are your possible outcomes here? So that's my sample space. We list them all. 1, 2, 3, 4, 5, 6. You do not just say there are 6. You list them out. And then the event shown on the die right now, Anish?
Should stop at 1.
Yeah, so my event would be what's the probability of rolling a 1?
1/6.
And we could then figure it out. It would be 1/6.
Is the spinner on blue?
Ah, Colin, what would be the action in my second column here? What would you physically do? Spin. So we spin our sample space, Ashley. What's in our sample space? Blue, red, and green. I'm just going to abbreviate those. And then, Dom, what's it look like to you? Where's that spinner?
Okay, well, I think it's on blue.
Yeah, it looks like it's on blue. So the event would be spin, stop, or spinner, stop at blue or on blue. And based on the spinner having equal size regions, what would that probability be? 1/3. So below these, we want to say, are they the sample space, are they the event, or are they the action? So, Julian, if I look at winning the game, is that action, sample space, or event? That's an event, right? That's what happened. If I win, that occurred. It did happen. Jeremiah,
Yes.
what about play a game?
That would be action.
Yeah, it's what you're doing. You don't know what the outcome is going to be, but the action that you're doing is playing the game. It's going to make something happen. Someone will win, someone will lose. And Samantha, win, lose, tie.
That's sample space.
That is all my options in sample space. I will either win, lose, or tie. Any questions on how we determine what the action can be, what the event could be, or what all options are in my sample space? So we get into 16.3. Evie, I would caution you're going to miss the intro to 16.3, so just make sure that you, yeah. So, relative frequency. What's it mean when something's relative? If you say, well, that problem's hard, relatively. Or, he's tall, relatively. Honestly?
Compared to something.
Compared to something. So, relative frequency, well, what's frequency mean?
Change.
Andrew? So you're right, like waves have frequency, but you've got a tiny bit of misinterpretation of what it is. Waves do have frequency. You're real close. Jaslyn? How many times something happens. So the frequency of a wave will be how many times it like has a maximum in a certain span, or how many times it hits the axis in a certain span. So that frequency is kind of a manipulation of how many times it happens. But this is how many times it happens related to, well, whatever we're talking about. So relative frequency of an event is how many times it occurs out of the total number of trials. Trials is every time we do something. So now you might want to highlight this. Each observation of the action counts as a trial. So when we observe the action happening. Now what this also means is you can't cheat. You cannot say, oh, well, that trial didn't do what I want it to do. I'll just ignore that trial. No, if you observed it, you got to use it. So that's like saying if I coin flip and I'm looking for what's the probability of getting 5 heads in a row. And you start with a tail and you're like, oh, well, I'll just ignore that one. I'll start out. No, it happened. Like you observed it. That was a trial. Unless you, like, so you can manipulate data in the way of like, I'll run this trial, but then I'll like step away and I'll start a new one over again. Like, but you still have that data that you collected. So here we have this spinner, and be careful to look at the spinner because as we get deeper into probability, everything is not fair. Okay.
What did you do?
I don't know.
Do something.
It's confused about whether I'm trying to highlight or what I'm trying to do. Take a second, look at your situation down there while I fight with this. Alright. So it says we're going to spin the spinner 40 times. We're going to keep track of the frequency of each possible outcome. 1, 2, 3, or 4. Find the relative frequency of each event as a fraction and as a decimal. So we would have to spin this 40 times. Right? So we spin, we spin, we spin, we spin, we spin. We collect all these outcomes. So let's say let's make some stuff up. Because it would take us a while to spin the spinner 40 times. Now we will do some actual like activity probability type stuff, but this is just to get us used to it. So let's say we get a 1 12 times. We get a 2 13 times. we get a 3 8 times, and we get a 4 17 times. I think that's too many, actually. Sorry, I think that adds up to 50, doesn't it? Yeah, that's too many. I gotta reduce this down. Sorry, let me make this up again. I did 50 instead of 40. Let's make this actually 9, 11, 8, and 12. Let's just do that. So that adds up to 40. So, if the event that we're looking for is spin a 2, we want to say, what's the relative frequency of that happening? So, how many, Sean, how many 2s did we get here? 11. Out of how many spins did we take? 40. So my relative frequency there would just be 11 out of 40. My spin and odd number, well, obviously my odd numbers are 1 and 3. So Jaslyn, how many times did odd numbers occur? You're not Jaslyn. Well, when you're speaking out loud and I called on somebody else, it's rude. You're good. I changed my numbers, so you maybe had so if we look at the odd occurrences, we've got 9 and then 8, right? So in total, how many odds did we get? 17. So this would be 17 out of what? 40, because still the total trials didn't change. So we could go further and say, what's the probability of a 4? What's the probability of an even? What's the probability of a prime? What's the probability of a number? Or what's the probability of a number? 100%, right? We're going to get a number no matter what on this spinner. We'd have to default to one or the other. So, try with this table below given to you. Did not mean to just clear that. But here are the outcomes. What is the relative frequency of the event spin a number less than 4? So now we ran 40 more trials. We've got slightly different results. So now, write down on your paper, what's the probability of spinning a number less than 4?
That's using the got it information, right?
Yes, that table. Because we did a different set of trials now.
How much time is friggin' Oh, wait a minute.
You do
I was switching the frequency outcome less than 4. Spin a number less than 4.
So, you would say, so we got to write it in probability notation. So to write this in probability notation, we need a P of your event that you're looking for goes in the parentheses. So what would go in the parentheses here?
Less than 4.
Yeah, the value less than 4. So you could either write it out, or you could say that. If we're saying X is the result of the spinner, then we'd say, okay, X is less than 4. Go on.
Wouldn't the frequency of the spinner, if you get a number less than 4, be 75% of the time because there's only 4 outcomes and 3 of them are below 4? So wouldn't that be 75% of the time
Nope.
you get less than 4?
Not at all. So this, hold up, is where the confusion between theoretical probability and relative frequency, and relative frequency has another name. It's at the top of your notes. It's experimental. Because when we do the experiment, we don't always get results that we anticipate. So, if we were talking about theoretical probability, then we could just do it based off regions of the spinner, but this is not even a fair spinner.
Yeah,
So if we were talking about theoretical probability, we'd look at 1, 2, 3, 4, 5 regions of the spinner out of 8, and the theoretical probability, don't write this down because it's not what we're talking about, but the theoretical would be 5 out of 8. But that's just what we guess based off what we see. We don't want to guess based off what we see. we want to calculate based off what we did. So we did this. We spun it 40 times based off the data that we have, not based off the spinner that we look at, based off the data we have. What's the probability of getting a result less than 4? That's like saying the probability of choosing a Phoenix student that is a boy is 50%. But if you actually walk into a class and randomly choose people, you might not necessarily get 50%. Because experimental, when we do it, does not always come out the same as the theoretical, what we think will happen.
And also, what's that equation down there? Is it just how to find the
Where? What?
that equation below
This?
the highlighted? Yeah.
That's not an equation. So this, make sure you're focused in with me because I just explained this. This is probability notation. This is saying the probability of the event goes inside. So I need you to write down on your notes because we talked about this yesterday, but I feel like you probably weren't paying attention. That's probability notation.
Oh.
P of the event.
Yeah.
And then that's going to come out to be whatever probability. So we now need to figure out, based off the equation given to us up there, relative frequency is amount of times it occurred over total amount of times it could have occurred. Andrew?
46 over 40.
So if I add up these, we get 26 over 40.
Verified.
Hmm?
Verified.
Sweet. Then we can reduce. We can make this simpler. What's it reduced down to? 1320, right? And if we made that into decimal form, 0.65. Now, 5/8, what we just talked about, the theoretical probability, that would come out to be 0.625. So our theoretical probability and what we got from our experiment are very close, which means it was a good experiment. We got results that we would anticipate. But we won't always get results that we would anticipate. We might have an experiment that kind of goes rogue, and I get a bunch of 3s. Even though 3 was a really small region, I could land on it a bunch of times. It might happen. I might get 10 heads in a row when I'm flipping a coin. That doesn't mean that the probability of getting a head is 100%, but in that trial, it might come out to be that way.
Where do you get the 65?
This came out of 5/8. So when we talked about the theoretical probability of those regions, there were 5 regions out of the 8 that are less than 4. So theoretically, what we would predict based off the spinner is this. What we got when we did it was this. Make sense? Questions? We're not really supposed to be talking about theoretical probability yet. It's the next lesson. But because we had the question, we might as well look at the comparison. So down here, same spinner. So if I was talking about the spinner, I'd say same unfair spinner. 1 and 2 have even chance of happening. 3 has a lesser chance, and 4 has a greater chance. So we still have that same table, same results. We did not run this trial again. So suppose the class spins the spinner 40 more times. Do you expect the relative frequency of the event spin A2 to change, or do you expect it to stay the same? So take a moment, write on here, using like words, what you would anticipate. If they do this one more trial, so they do this again, 40 more times. What would we anticipate to happen? And then answer B, too. Suppose if they spin the spinner 400 times. Is there a value that you expect the relative frequency of the event spin A2 to be close to? What would we expect? So this is predicting if we spin it 400 times, how many 2s would we get? So Manasa, if we were to do this 40 more times, what would you expect would happen to the frequency of 2? Do you think you'd end up with more than 12 or less than 12, and why?
I think we'd probably get a different answer.
Okay.
Would it be more or less?
What would you predict if you had to make a choice, whether you think it would be more than 12 or less than 12?
Less.
Why do you think that?
Because I'm going off the fact that there's a one.
There's a what?
No, I think I missed this.
Have confidence. What were you about to say?
There's like a quarter chance that the 2 will come.
This region is where my results that I'm looking for are, right? That region of 2. That region of 2 covers a fourth of your possible outcome space.
So out of the 40 trials, it stands to reason that 10 should be the last.
Yeah, we would think that we would probably get less, and we would probably expect 10 trials based off the size of the spinner and the size of the 2 section.
And for the 400 times, you probably get 120.
Now, why do you think that?
No, 100.
So that's where we got to kind of walk that tightrope.
What?
There's a fine balance. Walking a tightrope analogy, you got to balance. We ran a trial and got a frequency of 12 out of 40 for my 2s. But if we just look at what we see, we would expect 10 out of 40, is what we're saying. So if we spin 400 times, we would probably expect or anticipate that we're going to get an outcome of 2. Well, by the theoretical, we would guess 100. But by the experimental, we might think 120. So, I trust theoretical probability because it's predictions based off math. I was looking up quotes last night for my Math 1 class, and there was a really good one about theoretical, and I might have actually put this, I think I put this on your Schoology page, actually. I'm going to mute this really quick because I have, oh no, that's just the assignment page. It's fine. You can look at that. Probability.
I don't think you have it.
Maybe I did, or I thought I put this quote on here.
Yes, not.
So there's this really good quote about probability saying that experimental probability, what we're talking about right now, is using results to predict data, or using data to predict outcomes. Or I'll find it, but it's essentially they're inverses of each other. Theoretical probability is using what we see to predict the outcomes. Experimental probability uses the outcomes that we have to predict what we'll see. Can I help you guys? What's up? You got something to contribute? Does it have to do with math? So why are you talking? Sorry, you're just getting us off task. Like, if it has to do with math, I'd love to contribute. But otherwise, I only have 45 minutes, and we're running out of school days. Alright, let's move to the back. So really, if we trust theoretical probability, we would anticipate 100 outcomes.
What if you chose it to be like 110? So it's like
You could. Yeah, you could say between it. I mean, you're just making a prediction. So it's not necessarily right or wrong. It's all how you back it up. So, here again is your reminder of probability notation. P of an event is calculated by number of times the event occurs out of total number of trials. So, if we want to talk about the probability of... I should probably take a picture of that. I gotta reorient my screen to move that little doodad. wish it would let me move where it is. So, what's the probability that a customer asks for plastic bags? So try this on your own. What's the probability that a customer asks for plastic bags? We're going to write this in probability notation. So we're going to say P of plastic. Probability of plastic. Moon, how many occurrences of plastic were there from our 18 out of 32. So it says write it as fraction and as a percent. Did you get our percent here?
Not yet.
So we'll do the division, get your decimal answer, and then multiply by 100 to convert. What'd you say?
Oh, it's 3/4.
This comes out to 3/4 simplified. Perfectly. Nice.
Yeah, it wouldn't be 3/4.
So when I question, don't just say, like, did you check your math?
Yeah.
What number did you divide by to get to 3/4? So 18 can divide by 6. What's 32 give you when you divide by 6? So when I ask, are you sure? That means, like, have you verified your math? Have you checked your work? Do not blindly trust what you think. You gotta check the math, guys. That does not reduce to a fraction easy. It reduces close to 3, like, kind of close to 3. Like, what, yeah.
I got 56%.
Yeah. So, what could I reduce this close to? It'd be 3, if I divide by 6, this would be 3, and this would be 5, and another 2 over 6, so that'd be 5 point.
6.4.
Hmm?
Oh, wait, divided by 6?
Yeah, if we divided the top and bottom by 6, it'd be like,
Yeah, 5.3.
yeah, it'd be 3 over 5.3, and that's like repeating, and that's not very nice, but yeah, it comes out to 56%. That's why we don't care about the fraction form. We don't care about reducing it. This is perfectly fine. That communicates what I want to communicate. But then, a lot of times people would rather hear it as a percent.
I would.
Because people are used to percents. It ranges from 0 to 100. It's easy to think about. On the got it. What's the probability that a customer will bring reusable bags? And of course, this will change store to store. What store do you think might have a higher probability of people bringing reusable bags?
Trader Joe's.
Trader Joe's or Whole Foods, those hippie stores, right? People are going to bring their own bags. And I say that with love. By hippie store, I mean that's a good thing. The only reason I get plastic bags is to pick up poop in my backyard. My dog's poop. In case that needs clarified. Elena, what is your relative frequency or your probability of... Hey guys. Sorry, my smartboard went rogue there. That should say reuse.
8 out of 32.
8 out of 32. Now this can be reduced.
1/4.
To 1/4. So it as a percent? 25%. Very good. Did you have a question, Joe?
Oh no, I just really was excited about it being 1/4.
And working out. The experimental probabilities that you found in the example and the got it were based on data collection for 32 customers. Do you think these experimental probabilities are good estimates of the actual probabilities that customer will ask for these 3 types of bags? So take a second and write on your own paper, do you think this is good? And why? If you don't think it's totally valid or totally good, then what would you do to make it better? In your opinion, you as a statistician, person that does statistics, do you think this is a good measure and why? I'll come to you, but hang on to it for a second. But hold on. Let people make their own thoughts before you tell them what to think.
That's not my shot though. I was wondering if we're allowed to use like personal experiences that we've had to back up our evidence.
That's up to you. If you're the statistician.
This is hard work.
Now, the problem is, if you're saying personal experience, does that modify data? Does your own experience modify data that you've collected? Like when I'm at Kroger, I always get plastic bags. So does that affect the people that I collected data from?
you said, you may just...
Your personal bias should not affect the data that you've collected. It might affect how you interpret the data. What do you think, Monica?
I think that it's too small a sample to decide anything, so I'd like it for it to be a bigger sample.
What would a bigger sample do for us?
Because here with only 32 people, that's hardly like a good representative sample for a whole grocery store. And
Yeah, when you think about how many people probably check out at the grocery store, I mean, guys, we're talking thousands in one store in one day, probably. I mean, when I'm at the store, when you're at the store, you could probably look down the checkout lines and find 20 people checking out right at that moment. I mean, if you look at self-checkouts and everything else. Well, depending. I mean, like, I went to the store the other night and just didn't get a bag because I didn't need one. I was like, no, I'm going to carry this out. Just give me my receipt. Like, I don't like wasting bags, but yeah, 32 is not a very big sample when we're talking about hundreds and hundreds of people. So, to make this more valid, we probably want to get a bigger sample. Now, 16.4, especially with everything we've covered, should be very fast and very easy to discuss comparatively. Theoretical probability is not based on trials. Theoretical probability is my absolute favorite because it's just math. You don't have to do any trials. You don't have to collect any data. You don't have to talk to any people. You are just making predictions based off sample space and outcome space, or event space. So, if you don't know this yet, am a giant nerd. Love playing board games.
I have no idea.
So, there's a lot of probability involved in game theory. I'm talking about game theory as a branch of mathematics. I think you're talking about something specific. Okay, calm yourself. So, apparently I need to go look them up. I will. So, here's what's up. We can probably get through this whole set of notes in the 9 minutes that I get to keep you guys till our tornado drill. So, by the way, we're having a tornado drill at 9:50. I'm keeping you till then. So, chill. All we do in our tornado drill is, first off, you say nothing. If it's actually happening, it's gonna be loud already. The weather and everything outside, you need to be able to hear the adults that need to communicate to you. So first off, you make 0 noises. Second off, we, in an orderly fashion, which might involve waiting for a moment, but in an orderly fashion, we make our way down the central hallway, down as close to the gym area as we can get. You choose one side of the hallway, because up against the wall is going to be the safest place. In the middle, hey Dom, do you have like life-saving advice right now? Why are you talking? Why? You got the floor now. So is now the appropriate time? Can you make that judgment call on your own? Do we need to have lunch detention to discuss how you make judgment calls of whether safety concerns are more important or a mustache doodle is more important? This is your last chance. I'm really tired of this. Figure it out on your own, or we have to figure it out for you. So what did I just say?
You said that I should need this is my last chance.
Before that, about tornadoes.
Before the tornado, that we're going down to the gym area with the hall and we're down on the wall, because that's the safest area for tornado was actually happening.
Which way do you face?
Face towards the wall.
I didn't even get that far. So you guys have done this before, right, is what I'm getting at. Biggest thing is location here. we have very few windows. We have a very safe building. For as much as I don't like our building's extremely safe because we have very few windows. So, based on the construction of the building, that space of the hallway is the safest place for if stuff starts crumbling and crashing and whatever. Down here, there's some stuff up in the ceiling and whatever else. You'd still be relatively safe down here, but there's just more open space. The hallway being so close together, if something falls, the hallway will protect you because there's only like a 6-foot span there.
All schools build basements.
Those aren't any safer anyways.
They are?
No, I mean, in your house it is, but if you have like a giant building like this, on the ground floor, up against a wall is just as safe as you would be in a basement up against a wall. Yeah. Basements aren't necessarily safer. It's just how your house is constructed. Your house has a higher probability of collapsing than the school does. Because your house is made with wood, schools are made with brick and mortar. So that's brick and mortar stronger than
Why are
wood.
you against the wall?
Because the wall's strong. The wall is protecting you because when something falls and tries to hit me, it could either hit the wall and go that way, or it will lean up against the wall and I'm still protected against the wall.
The wall's straight.
I know. So it's not 100% safe. It's as safe as we can get. So, moving on. Did not mean to take that long on that. At 9:50, he'll come on the announcements, announce that, we'll head down. So, theoretical probability is all based off what we see. So the probability of rolling a 0, well, how many zeros are on that cube? This cube, this is why we list out the sample space. My sample space is 0, 1, 2, 3, 4, 0. So I have 2 zeros out of 6. My probability reduces to 1/3. Doesn't matter how many rolls we take or anything, because we don't care about any of that. We just care about what we see. Any questions? Situations that people often talk about involving theoretical probability. Toss a coin, roll a cube, spin a spinner. You can make the spinner have as many sections as you want it to be. So you take the circle, 360 degrees, divide 360 by how many sections you want. That many degrees, or that answer will be how many degrees you need to make each wedge. So, if I look at this spinner, and theoretically we want to talk about each of these probabilities, take 30 seconds and try to get all 6 of these down. I bet you can't.
I can't see the yellows.
It's green, blue, red.
Okay, whatever. Red, 1, 4, 6.
5 seconds.
Yeah, no, not happening.
Wait.
Keep going.
I did it.
Oh shit.
Alright, Dom, what's the probability, theoretically, of getting a red?
Red, I said.
Good morning. Please pardon the interruption. In approximately 5 minutes at 9:50 a.m.
9:50.
Alright, so probability of a red,
I said that was a 3 out of 8 chance.
3 out of 8. Probability of a red with an odd. Ashley? Well, so how many reds have odd numbers? 1. How many total outcomes? So this would be 1 out of 8.
Oh, I thought that was saying like red with an odd.
No, 1 spin. That gets you a red odd.
Gotcha. That makes more sense.
Elena, what about probability of green?
2 out of 8.
Reduce it.
Oh.
1/4, right? 2 out of 8 reduces to 1/4. Anish, what about a number less than 10?
That's 100%.
Yeah, that's 100%.
Or just, could we write just 1?
Andrew, probability of yellow.
0.
0. There are none.
Instead of 100%, can you write
Yeah, you
1?
can. Noah, probability of blue with an odd number.
2 out of 8.
2 out of 8 or 1/4. We have a bag of buttons as opposed to a box of buttons or a bag and a box of buttons. So, what is the probability of choosing a blue button here? You'll probably need to look up at the screen.
I can't even see them from here. I think that's 6.
Yeah.
6 out of 10, I think.
6
I'm gonna call
out
it
of
eight, but-
12, which really is
1/2.
1/2. Ozzy, what about probability of choosing a 2? We'll move on. You can't see that well enough.
I moved their images very fast.
So, in the NICU, the infant area at the hospital, they are saying that the probability of birthing a boy is 50%. So they're saying that there are even male-female births. Like if they're equal, if we are equal. So Phoenix, our probability of boy-girl is 50%. McCord, their probability of boy-girl probably is not 50% because they can't make that happen. So if this is our data on boy-girl births, and we compare boy births to total births, ooh, do we get a 50%?
No.
No. So what statement could we actually make based off this data?
The number of boys
So you could say having or birthing a boy
is more likely.
Birthing a boy is more likely than birthing a girl. So if you are pregnant, this data, I forget what year this was collected in, but this is U.S. data from a year. Birthing a boy was 51%, birthing a girl was 49%. There's a 2% difference. So, hold up. Let's talk about comparison, because your homework merges experimental and theoretical. Sometimes it's asking you experimental, sometimes it's asking you theoretical. If a soccer player took 12 shots, is that experimental or theoretical?
Experimental.
Experimental. He did it. Guys, we're coming back here. You're not taking your stuff with you. You don't have to be totally packed up. Like, we're just going with just you, your body. You roll a standard number cube 50 times. Mr. Williams, is that experimental or theoretical? If you rolled the cube 50 times. Yeah, you did something, right? You're not talking about the math. You did it. Yep. Jaslyn, what about you choose one tulip at random and you're...
The tornado sirens are now sounding. Please
This
take shelter.
would be theoretical. Silent.